Hey everyone, it's Mr. Rosenberg again. In this video, we'll be starting Chapter 4, Section 8, where we're going to be talking about complex numbers. So the objective is to identify, graph, and perform operations with complex numbers, and then to find complex number solutions of a quadratic equation. But before we do any of that, we need to talk about a new type of number we're going to be dealing with. And that's the imaginary number I. Yep, we're not done with, but real numbers have gotten us so far, but now we have to bring in imaginary numbers to help us out. So first, the complex number system is a set of numbers that include both real numbers and imaginary numbers. And complex numbers are based on the imaginary number I. And the imaginary number I is a complex number whose square is -1. So that means I squared is equal to -1, and I is equal to the square root of -1. And this piece of information is what's going to help us solve problems where we're going to have complex number solutions. All right, so if you take away anything from this slide, take away this definition right here, that I is equal to the square root of -1, and that I squared is equal to -1. Now, the imaginary number I was created to solve equations such as x squared is equal to -1. All right, so here's a little rule we have. It says if r is a positive real number, then -r is equal to I, or then the square root of -r is equal to I times the square root of r. So let's see how that applies here in this equation. So here we have x squared is equal to -1. So if I were to say solve this equation for x, we would have to take the square root of both sides, and we would end up with x is equal to the square root of -1, right? So here, this number 1, that's our r. So -1 is -r, like we have up here. And then if we simplified more, we would get x is equal to I times the square root of 1, using this rule we have up here, this definition. And then we know that the square root of -1 is just 1, so we end up with x is equal to I. All right, so we have I is equal to the square root of -1. That's what we used here. So now that letter I, or that number I, it helped us take the square root of a negative number, like we just saw. So if we work on this example here, we want to take the square root of -25. So to do that, we have to apply our rule that's down here in the bottom right corner. Right here, 25 is our R value, so the square root of -25 should just be equal to I times the square root of 25. And now from here, we know what the square root of a positive 25 is. It's just 5. So we get this is equal to I times 5. And then just for standard notation of how we write out these imaginary numbers, we just write it as 5I. Now let's try it again, taking the square root of -50. All right, again, we're going to apply this rule down here. So our R value here is 50, and we have a -r, -50, under that square root. So this will become I times the square root of 50. All right, now we just have to take the square root of 50, and we're basically done. Right, so the square root of 50, to do that, it's not a perfect square, so we can break this down into I times the square root of 25 times the square root of 2. And now from here, the square root of 2, that can't be broken down anymore, but we can simplify the square root of 25, because the square root of 25 is 5. So now we have I times 5 times the square root of 2, and now we just have to put it in that typical mathematical notation. So this is equal to 5i times the square root of 2.